Okay. Determine if the sequence is arithmetic or geometric, and we already talked about the difference. Arithmetic is when you are adding or subtracting to get to the next number. Geometric is when you are multiplying to get to the next number. Then once you've determined what type of sequence it is, write the recursive and the explicit formula for the sequence. Now, all of those formulas are over there on the whiteboard, so you just have to know what to plug in and where. So Zaire, for number 1, is it arithmetic or geometric? Geometric. And why is that? Correct. Every single time to get to the next number, you're multiplying by 1/2 or 0.5 if you make it a decimal. Now, I notice some of you look at that, and the first thing that pops in your head is divided by 2. But with geometric sequences, you're always looking for what they're multiplying by. And dividing by 2 is the exact same thing as multiplying by 1/2. Okay, let me show you on a calculator. Look at this. 550 divided by 2 is 275. 550 times 1/2 is also 275. So dividing by a number is the same exact thing as multiplying by the reciprocal of that number. Reciprocal is just when you flip it. Isn't 2 2 over 1? So when you flip 2 over 1, it becomes 1 over 2. You're just multiplying by the reciprocal of what you were trying to divide by. So dividing by 4 would be the same thing as multiplying by 1 over 4. Dividing by 10 is the same thing as multiplying by 1 over 10. So if the first thing that pops in your head is division, you just quickly change it to multiplication by flipping it. So dividing by 2 is the same thing as multiplying by 1 over 2. So that is our R. Now that you have the R, what else do you have to be able to write the explicit formula? Right, and for this sequence, the first term is what? 24. So we need this A sub 1, and we need the R. And then that means the explicit formula will just be A sub n equals A sub 1, which is 24, times the R, which is 1/2, raised to the n minus 1. Now, that formula can now be used to find any term they ask for. So, like if there were a part B of this question and it now said find the 25th term, you could just replace the n with a 25 and type it in, and whatever number you got would be the 25th term in that sequence, instead of having to write out all 25. Okay, now for recursive, it's even easier. Look over there on the whiteboard at recursive formula under the geometric side. It just starts A sub n equals A sub n minus 1 times the R. And we know the R is 1/2 because that's what they were multiplying by every time. So we're done with number 1. We found the common ratio because it's geometric. They're multiplying by 1/2. And then we wrote the explicit formula and the recursive formula. Now let's do number 2. Is it arithmetic or geometric? It is arithmetic. Why is it arithmetic? Right, and when they're adding, you use D for common difference. What are they adding? Right, so it's a positive 3. Now, for recursive, it's just as easy. It's just A sub n equals A sub n minus 1, but we're not multiplying anymore, we're adding by 3. So recursive is very simple, but it's also not very useful. Okay, I mean the only time, like you may see a question where it gives you the recursive formula and tells you to find the next 3 numbers, and you'll just have to know, oh, well, to find the next 3 numbers, I just add 3 every time. Okay, but other than that, it's not a very useful formula. Explicit is more useful because in the explicit formula, you have the first term and what they're doing, which in this case, they were multiplying by 1/2. For the explicit formula of an arithmetic, it's A sub n equals the D, which we found out is 3, times n minus 1, plus the A sub 1, which is what? -4. The A sub 1 is the first term, and that's -4. The explicit formula for arithmetic is the most difficult out of the 4 because at this point you actually have to do some math. You have to simplify it. And what would we do first to simplify that? Right? and that would become 3n minus 3. And then isn't a plus a negative 4 just a minus 4? So that would simplify to 3n minus 7. Now, if you do not want to have to remember how to do this, like how to plug in the d and the a sub 1 and then distribute and combine like terms, you can remember the shortcut method is a sub n equals your common difference times n plus the 0th term. We know the common difference is 3, and then if we went back to the 0th term, wouldn't that be back to negative 7? So if you can remember that, then you don't have to do all these steps. If you can just remember that in the explicit formula, you always have the common difference beside the n, and then at the end it's the 0th term. But if you cannot remember that, you're going to need to plug in to the d and to the a sub 1 and simplify. Okay, now, doesn't the explicit formula for a geometric look very similar to y equals a times b to the x power? You have basically your y equals in the place of a sub n, and then 24 is in the place of a, b is, or 1/2 is in the place of b, and then the n minus 1 is the exponent. If you graph this, it will make an exponential function. Okay, let's graph it. Well, you can just watch me. 24 times 1/2 to the n minus 1. I'm just going to type in 0.5 to save time. Oops, that's not 5. Okay, when we graph it, we see that it will graph an exponential decay, but I didn't graph this yet today. Oh yeah, there it is. Why is it a decay? Why is it going down? Look at the equation again. It's a decay because look at your b value. It's less than 1. Oh, sorry. I thought you said something about the 24. Okay, so anytime, remember, your b is less than 1, it's going to be a decay. And in this, the numbers are going down. They're decaying. They're decreasing. Doesn't the explicit formula for an arithmetic sequence look like y equals mx plus b? So it's going to make what when you graph it? A line. It has a slope of 3 and a y-intercept of negative 7. Okay, so arithmetic sequences are linear. Geometric sequences are exponential. Because think about it, arithmetic sequences have a constant rate of change. Don't they go up by 3 every single time? And constant rate of change is linear. Geometric sequences go faster and faster. Like in this case, first it goes down 12 units, but then it only goes down 6, then it only goes down 3. So the rate is slowing down, which is why it looks like this. It's slowing down and leveling out. That's what makes it curve, because it's not a constant rate of change. First, it's just down by 12, then down by 6, and down by 3. So the curve flattens out. Okay, now turn in your packets to page 5. We're going to skip around in the packet, so start with page 5. All right, and on page 5, the very first section, 1 through 6, the directions are: tell whether the sequence is geometric, explain why or why not. So for number 1, is that geometric? Okay, why is it geometric? Correct. To get from one number to the next, all they're doing every single time is multiplying by 2. So that means the R for common ratio is 2. Number 2, is it geometric? Okay, why? What's going on? Right, every single time they're multiplying by 10, so the common ratio is 10. Number 3, it is, because what are they multiplying by every time? Okay, and then number 4, is it? It is no. At first it may appear to be, because to get to 16 to 8, you just multiply by 1/2, but then 1/2 of 8 would be 4, and that's not a 4, so this is not geometric. Number 5, is it geometric? It is, because what are they multiplying by? 1/5. Because when you look at it, you may think immediately dividing by 5, but isn't that the same thing as multiplying by a fifth? And in geometric, we multiply. So you got to figure out what they're multiplying by, not what they're dividing by. Okay, number 6 is a little trickier. It may help you if you look further into the list. Like if you just kind of ignore this first term at first. Now, how are the numerators changing? Well, but what are they multiplying by to get from one numerator to the next? 1. And then what are the denominators multiplying by? Right, so the ratio is 1/3. Now, some of you still may be confused about that first number. Look at the first number. 3/4 times 1/3 is 1/4. Watch. 3/4 times 1/3. When you multiply, you just multiply straight across. 3 times 1 is 3. 4 times 3 is 12. And 3 divided by 12 reduces to 1/4. So all they're doing every time is multiplying by 1/3. But if you're not able to see that from the first term to the second, move further along in the sequence and see if you can figure it out then. All right, the next section, the directions say, write a rule for the nth term of the geometric sequence and then find a sub 6. Anytime they say write a rule for the nth term, they're just saying create the formula so that we can find any term we want, so that we can plug a number in for n. So what are the things that you have to be able to create the formula? The a sub 1, which in this case is, and what else do you have to write the formula? Which in this case is 2. And then to write the formula is just a sub n equals the a sub 1, which is 4, times the common ratio, which is 2, raised to the n minus 1. Anytime they say write the rule, they're talking about the explicit formula. Because it's the one where we could actually plug in for n and get whatever term we're looking for. And in this question, what term are they looking for? The 6. So what do we do with 6 if we're trying to find the 6th term? Plug it in right here. So it'll be 4 times 2 to the 5th power. Does everybody see where I got 5th power? Because if you plug in a 6 there and minus 1, that's 5. Now calculate that and tell me what the 6th term is. 128. Okay, now let's make sure that actually makes sense. They gave us the first 4 terms. So we're trying to find the 6th term. So we need to find the 5th term. And what would it be if you're multiplying by 2 every time? 64. And then if you multiply by 2 again, you get 128, which is the 6th term. So in a problem like this, where they already gave you the first 4, it's almost faster just to literally write out the 5th and 6th. But on your test and on the EOC, they may ask for like the 25th term. And it will be way faster to just plug in 25 for the n in your rule instead of writing out all 25 numbers. Okay, number 8. What is the first term? 5,000. And what is the common ratio? What are they multiplying by every time? They're dividing by 10, but we're looking for multiplying. So dividing by 10 is the same as multiplying by 1/10, or 0.10. Okay, now that we have that, we can write the explicit formula. It's a sub n equals the first term times the common ratio. And if you don't want to write that as a fraction, you can write it as 0.1 or 0.10 to the n minus 1 power. Yeah, up here. Okay, now to find the 6th term, you simply plug in a 6. So you'll end up with 5,000 times 1/10 to the 5th power. And what do you get? 0.05, right? Okay, y'all take a second and try number 9 by yourself. Okay, what is the first term? What is the common ratio? So the formula is a sub n equals, and so to find the 6th term, it would be 3 times 4 to the 5th power. And what is that term? Right. Any questions so far? Pretty easy, right? Okay, the next section, the directions are write a rule. So again, write the explicit formula for the nth term of the geometric sequence. Then graph the first 5 terms of the sequence. Well, to write the rule, what do you have to know? The first term, which we got, 1, and the ratio, which we got. So we can go ahead and put those right in the explicit formula. The first term goes first, and then times the r value to the n minus 1. Now, besides writing the rule, they also asked us to graph the first 5 terms. Well, they already gave us the first term. It was 1. So we need to find the second term, the third term, the fourth term, and the fifth term. And what's the easiest way to do that? You could graph it and go to the table, but considering these are small numbers we're working with, what do you have to do to get from one term to the next in this problem? Just multiply by 2. So if you start with the first term, which is 1, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the sixth term would be nobody knows what this 32. 16 times 2 is 32. Yep, because the r is 2. Right. Okay, now when we go down to plot these points, okay, first I want you to notice that the x-axis is numbered by 1. See the little 1 right here? And then the y-axis is numbered by 3. So this is 3, 6, 9, 12, 15. Okay, so what you have here is if term 1 equals 1, that is the ordered pair 1, comma 1. Well, when I go to plot that, you got to be careful because you will go right 1 because the x-axis is going by 1, but then do you go up 1 full block? You only go up like a third of the block, correct? Okay, then the second term is 2, so that's the point 2, comma 2. So that's right 2 blocks and then up 2/3 of the way. And then the third term is 4, so that's the point 3, comma 4. So I go right 3 and then up, this is 3, so 4 would be like right there. And then the fourth term is 8, so that's the ordered pair 4, comma 8. Right 4 up 6, 9, so barely under that line where 9 is. And then the fifth term is 16, so that is the point 5, 16, which is right 5 up, right above the line for 15. Can't you see that this curves? It's an exponential graph. Because doesn't this look like y equals a times b to the x? Now, do you think I should connect the points? No, not in this case, because the points represent the first term, the second term, the third term, the fourth term, the fifth term, and we could continue plotting for 6th, 7th, 8th term, but is there information between the first and second term? Is there like a first and a half term? No, so there's no information between the points, which is why you do not connect them. Okay, number 11. We're going to write the explicit formula first. So it's a sub n equals what? Try again. Courtney got it. It's 5. And why is it 5? Correct. This time they gave you a sub 2, which is the second term. So you've got to find a sub 1 by working backwards. 15 divided by 3 is 5. I wrote 3. Does that make sense? So that means 5 goes in your a sub 1 spot, then times the r value, which is 3, to the n minus 1. So now we already have the first and the second term. We've just got to find the third and fourth and fifth term before graphing them. Okay, well, to get from one term to the next, all you're doing is what? Multiplying by 3. So that would make the third term and the fourth term and the fifth term right. Okay, well, on this graph, you'll notice that the x-axis is numbered by 1s again, but the y-axis is numbered by 100. So that's like 100, 200, 300, and up. So to plot the first term, 1, comma 5, you're going to go a full block to the right for 1. But then 5, I mean, this is all the way, this is one block is 100 units. So wouldn't that mean up 5 is going to pretty much look like it's sitting on the x-axis? And then the next point is what? 2, 15. So that's right 2. 15 will just be a teeny bit higher than the previous point. And then what's the next point? So right 3, and then since this goes to 100, 45 is going to pretty much appear to be in the middle of the block, right? And then what's the next point? 4, 135. Well, this is 100 and that's 200, so 135 is going to be below halfway, so about right there. And then 5, 405 will be right 5 up, 100, 200, 300, and 405 is going to pretty much look like it's sitting on the 400 line. Now, see how both of these are growths? They're exponential growths? Because this one's doubling, so it's growing. The numbers are getting bigger. This one's tripling. Should I connect the points? No, because there's no information between the first term and the second term, or the second term and the third term. Now, you try number 12, and the common ratio is 2/3. What would that make the a sub 1, the first term? 81. Because if you're having to go backwards, you divide by the common ratio. And 54 divided by 2/3 is 81. That would make the formula a sub n equals, correct, and then the third term would be, and then the fourth term would be, and the fifth term would be 16. Okay, now when I go to graph it, I see that the x-axis is by 1s for the first, second, third, fourth, and fifth term. And the y-axis is by 20. So 20, 40, 60, 80, 100. Okay, the first point I'm going to plot is what? 1, 81. So right 1 up 81. The second point is going to be 54, so right 2 up 54 would be about right there, more or less. The third point will be 3, so right 3 up slightly below the 40 line. The fourth point will be 4, so like about right there. And then the fifth point is at 16. Okay, see how this one curves? I should go a little higher, I guess. But it's a decay. Okay, because what would the sixth point be? What's 16 times 2/3? So it would be like about right there. So yeah, see how it's starting to flatten out down there? But it's a decay because look at the growth or decay factor. It's 2/3. The numbers are getting smaller because the number is less than 1. Okay, now I'll turn to page 4. Find the constant ratio and write the explicit formula for the nth term of each geometric sequence. So first they want us to find the constant ratio for each one. And then after finding it, they want us to write the explicit formula. What is the ratio for number 1? Correct. And so the only other thing you have to be able to write the explicit formula is the a sub 1, in that case 1. So the explicit formula would be a sub n equals the first term, which is 1, times the common ratio, which is 3, to the n minus 1 power. Does that make sense? Okay, what about number 2? Does anybody know what they're multiplying by each time? 5 or 5 over 1. Now, for those of you who don't know how to get that, break it down. First, just look at the numerators. On top, and it just 5 times 5 is 25. 25 times 5 is 125, and so on. And on the bottom, they're all the same, so they're just multiplying by 1 over and over. Well, 5 over 1 is just 5. So now the explicit formula would be a sub n equals what? Right, the first term times to the n minus 1. Okay, for number 3, what are they multiplying by each time? Right, negative 0.5, or if you want to write it as negative 1/2. Either way is fine. Good. Because they're not multiplying by negative 2, they're dividing by negative 2, which is the same thing as multiplying by negative 1/2. Remember, we don't care about dividing with these, we care about multiplying. So that would make the explicit formula a sub n equals times to the n minus 1. Okay, number 4, how do you get from an 18 to a 9, a 9 to a 4.5, and a 4.5 to a 2.5? 2.25 by multiplication. Very good. Multiply by half, which is the same thing as dividing by 2. Now that's a sub n equals the first term times, right. Okay, now turn to page 3. Okay, on page 3, it's 4 parts for each sequence. Part A says find the ratio of each sequence, and you'll put it right here beside R equals. Part B says find the next 3 terms. Part C says write the recursive formula, and I'll go ahead and I would, if I were you, write it down on your paper. The recursive is a sub n equals a sub n minus 1 times the R value. And then part D says write the explicit formula, which is a sub n equals a sub 1 times the R raised to the n minus 1. You're just filling in the blanks. Yes. Okay, so for number 1, what is the R? What are they multiplying by every time? 3. So that would make the next number, and then 81 times 3 is, and 243 times 3 is 729. Now, the recursive formula is the easiest because all it is a sub n equals a sub n minus 1 times the R. The explicit formula is not much harder. You just have to throw in the a sub 1 also. A sub n equals the first term, which in this case is 1, times the common ratio, which is 3, to the n minus 1 power. Just the first term times the R raised to the n minus 1. And that is the formula that's actually useful. Like if they ask for the 100th term now, all you would have to do is plug in 100 for that n and calculate it. Okay, number 2. What are they multiplying by each time? If you look at the beginning and you're not sure, skip further over in the sequence. 10. And so that would make the next number 1,000, and then the next one, and then the next one. Okay, so the recursive formula will be what? Right. A sub n equals a sub n minus 1 times 10. The explicit formula will be a sub n equals, correct, 1/10, because that's the first term, times the common ratio to the n minus 1. So does everybody see what you're doing on these problems? Okay, what about number 3? What are they multiplying by? 1/2 or 0.5. And so the next number would be 1, and the next number would be 1/2 or 0.5, however you want to write it, and the next number would be, right, or 1/4. You can write it as a fraction or a decimal. So the recursive formula would be a sub n equals a sub n minus 1 times 1/2 or 0.5, however you're choosing to write it. The explicit formula would be a sub n equals the first term times, right, to the n minus 1. I mean, yeah, you can, but it'll look kind of funny, but you can. Okay, now you need to finish 4 through 10 on your own. We still have 6 minutes in class, so we're not going to switch out yet. But whatever you don't finish is your homework.